Hello everyone, I'm Lorem, and today I'm going to be doing a short tutorial on how to use my Procedural Swords tool, built using geometry nodes in Blender 3.5. This tool is great for creating a wide variety of different swords and is available for free on my Gumroad. You're more than welcome to use it in any commercial or personal projects, no attribution required. Alright, let's get into it. First things first, we can add any new geometry, add a geometry nodes modifier, and set that to sword gem. As you can see, we've got our default sword. Now, for this tutorial, I'm going to go through all of the different inputs, as well as the different important elements of the node tree that you can use to really maximize the potential of this tool. So, starting out, we've got the seed. The seed is used to generate different noise patterns, which are used for various things throughout the sword creation. Namely, blade chipping is a big one, where you might want to change the seed. Next up, blade material. Just allows you to change the material of the blade. There are a few different textures included with this, and I highly recommend you check them out. Alright, next up we have blade size, which is a vector. Blade size on the X increases the X size of the blade. Blade size on the Y increases the Y size of the blade, and on the Z changes the Z size of the blade. Really simple. Alright, so I'm going to make mine a little tall like that, and then we can move on. Alright, next up we've got the blade resolution and the blade profile resolution. As we change this blade resolution, you can see that the vertical resolution of the sword changes, and then as we change the profile resolution, you can see that the horizontal resolution changes. I recommend setting the blade profile resolution to a multiple of 8. That produces the cleanest results. You don't have to, but if you don't, they might look a little bit weird. Alright, as we look at the blade resolution, we should also look at this blade width ramping that's in the initialize blade node group. What this does is it controls how sharp the tip of the blade is. So if we go ahead and zoom in on that, you can see as I pull this in closer, the tip gets kind of more blunt and wider near the top. But as we bring it down, the tip gets pointier and pointier. So we'll have it be something like that for now, and yeah, we can just leave it like that. Alright. Next up, we have the blade profile, which has its own node group, and again, it's got a highlighted float curve, which means that it's going to be pretty important. And I'll go ahead and just exaggerate this so that we can really clearly see what's going on. So the blade profile on the left controls the base of the blade, and on the right controls the tip. And as you can see, as we kind of alter this, we can get a bunch of funky shapes going on. And then this blade profile input is used to multiply the result of this float curve. And this blade profile asymmetry boolean prevents the blade profile from being used on one half of the blade. So if you want to make a single-edged blade, what you can do is take the blade size Y and bring it down pretty small, and then crank up the blade profile. And as you can see, now we've got this nice one-edged blade, and if we wanted to do something like that, there we go. But you may have noticed this blade is now off-center. And to fix that, we can use the blade offset. We can just increase that until it's about centered, and there we go. Now, you'll notice that I skipped over the blade curve. So let's take a look at that right now. The blade curve, as we increase it, we curve it to the right, and as we decrease it, we curve it to the left. I think for our purposes, we will be making a curved blade. So let's see. A curve like that should be fun, and then if we want, we can also rotate the blade to kind of have a more pleasing overall shape. And then I want the profile to be not that low, to come down at the base like that. And then I want the blade profile, let's increase it, turn that down a bit, bring that down, bring it back towards the middle, and there we go. And then what we can do, if we don't want this curve to be quite like that, we can bring this down. And so if we want to make like a nice scimitar, you know, we could have it be very blunt at the top, or bring it, ooh, whoops. Or we can have it be kind of smooth and rounded. And I think that's what I'll do. I think I'll leave that about like that. That's fun. All right. Next up, we can look at the blade chipping. So this is just a Boolean, and when we enable it, you'll see that the edge is now chipped. It's pretty straightforward. However, it does take a while. It's pretty slow. As you can see, that took 209 milliseconds to execute. Mesh Booleans are notoriously slow. So what I would recommend doing is get your blade chipping set up how you like, and then disable it until you're ready to actually apply the modifier. And then if we increase the blade chipping amount, you'll see that, well, the blade gets super chipped. So if we want to have just a little bit, we can do something like that and just have a few chips. I think, yeah, we'll do something like that. That's fun. And then this blade chipping is intrinsically tied to the blade resolution. A higher resolution will have more chips, and vice versa. So you want to make sure that you're, you know, working with those two in tandem. Next up, we've got the blade Zwei curves, as in the curves that are seen in a Zweihander. And as you can see, when we enable that, nothing really happens. We get this kind of weird curve here, but what we can do is down here in blade Zwei frequency, we can turn that up. And as you can see, we start incorporating a sine wave into the blade. So let's see. And this is another modifier that is intrinsically related to the blade resolution. The higher the blade resolution, the more sine waves are going to be put into the blade. So I think for our purposes, we'll have a blade resolution of 64. And then, let's see, I want quite a few curves, but I don't want them to be quite as strong. So we can turn the amplitude down. And then, let's see, I don't love this meeting point right here. So what we can do is we can offset this curve, right? So I'll just offset it to something like there, so that is a nicer gradual transition. And then looking at this, I don't love the way that it's kind of coming to a point at the top. So I'm going to revisit the blade width ramping and bring it up just a bit. And I like that a whole lot more. All right. So those are our Zwei curves, and then that is compatible with the blade chipping. As you can see, we've got, you know, some nice chips going on. Go ahead and disable that for the time being. And those are really all of our blade options, at least for now. There's a couple other extraneous things that you can do to the blade, but those are towards the end of the modifier setup. All right, so now we can move on to the handguard. Our first handguard input is the material, and the default is just steel, but you can set it to be quite a number of different things. There are, I think, 4 textures that come with the setup, and they're just pretty basic colors for the most part, but they work. All right. Next up, we can look at the handguard asymmetry and handguard pillowing. We'll start with handguard pillowing. If we enable that, we can see that the handguard has pillowing on it. And now this pillowing is intrinsically tied to the resolution of the handguard, as you can see. And we'll go ahead and disable that for now. Next up, we have the handguard asymmetry. And if we enable this, nothing happens. But that's because we don't have a handguard curve. If we increase our handguard curve, we can see that it's going in different directions. And then if we uncheck the asymmetry, we can see that it's going in the same direction. And so we've incorporated a bit of a curve here, but we've got some clipping going on, and I don't really like that. So what we can do is, if we go to our handguard node group, you can see we've got handguard curve. And I'm going to take this point and I'm going to bring it down so that this does not, so that the center of the handguard is not influenced by the curve. And that way we can, you know, have this curve go crazy and this blade won't clip through it at all. I think I'm going to let's see, set it to be something like that, and then we can take a look at the handguard thickness. This is another important node that is not in the outputs, and it's highlighted in orange. So what this does is it decides how thick or how thin the handguard is in certain places. So this end here on the right is the outside edge, and then this end here on the left controls the middle of the handguard. So, and you're able to create some pretty nice looking, patterns with this, and you can change the blending here. We can increase the handguard resolution to something kind of high, and then by changing this blend mode on the color ramp, we can get totally different looks. So that's fun. Not really what we're going for, so we'll stick with something like that. And then let's see, we can make that bigger, bring that in a bit. All right, so next up we have the handguard size vector. And what this vector does is it controls the handguard size. So the X controls the X size, the Y controls the Y size, and the Z controls the Z size. So if I want to make this handguard a bit wider to kind of fit better with the blade, we can do that pretty easily. And then we can also make it, thicker, thinner. I think we can make it a bit thinner, and then that's good. Now, we've also got handguard subdivision, which applies a subdivision surface modifier to it, and then we can control the edge crease of that subdivision surface modifier. We'll go with that. Now, we can also add studs to this handguard with the handguard studs option, and you'll see when we enable it that it instances studs on every single point, which is not what we want. So what we can do to fix that is increase the handguard stud amount. And as you can see, this is a modulo, so less is more. And then we can change the size of these handguard studs, and there we go. Let's see. We'll go with that many. Well, got one out on the end that I don't really want. There we go. Yeah, that works. Sure. All right. Next up, we've got our handle options. The first one, as always, is the material. There are several different handle materials to pick from that are included in this. There's a nice, kind of ribbed leather one. There's knurled wood. There's cloth. I think for now, we'll go with a nice blue ribboned cloth. All right, and then we can change the resolution of this handle. And because this handle works by instancing a curve and then instancing a curved circle along it to form it into a mesh, as we increase the handle resolution, it increases in both dimensions. So we'll set that to, 32 for now. We want to go with something kind of high poly. And then if we go into the node tree, into the handle node group, you'll see that we have this handle profile color ramp. And what this does is it controls the profile of our handle. So on this left side, if we make it bigger, we'll see that the top of our handle gets bigger, and then we can make it a bit smaller, and then we can move this larger part up and down. And again, just like on our other color ramps, we can change the blend mode of this to get totally different results. So if we want constant, I don't know why you would want that, but if you wanted to make something super geometric, you could do it. Linear, cardinal. I tend to like cardinal, so we'll stick with that. And then let's see, do we want to make this bigger at all? Yeah, sure, we'll go with something like that. All right, then we can choose the length of our handle using handle length over here. Let's see, and I want to choose something that is proportional with the sword. So we'll go with, yeah, something like that. Nice 1.5 hand looking thing. Then we can change the thickness of the handle, and this thickness controls the overall thickness. And that's looking a little bit too big. We'll bring it down to right there. But then you may notice we've got a bit of a problem up here. The handle is clipping into the handguard. What we can do to fix that is go right down here to handle depth, which controls the X size of the handle. So we can just decrease that and then it'll fit nicely. I think I'm actually gonna tone it down to 0.8 to get a nice oval shape going on. All right, we can also change the curve of this handle. So as you can see, a larger curve means a bigger curved handle, etc. We'll set that to 0.7, and then that does not look right, you know. So what we have to do is change the tilt of our handle accordingly. And we'll just go with something like that. And then, you know, obviously a larger curve will lead to a larger tilt. All right. And those are our handle options. Next up, we've got the pommel options. So first up, we've got pommel pillowing, which just controls if these faces are extruded a bit or not. I find that it creates a nice little effect. And then we've got pommel shape. There are 5 pommel shapes: 0, 1, 2, 3, and 4. 0 is a cylinder, 1 is a cube, 2 is a UV sphere, 3 is an icosphere, and 4 is a curved circle with another curved circle instanced along it. We'll go with 0 for now, just so we can demonstrate some things. Next up, we've got pommel resolution, which, as you may have guessed, controls the resolution of your pommel. For 0, it controls the overall resolution of the cylinder. For 1, it controls this is technically the Z resolution of the cube. For the icosphere, it controls the resolution like that. For the UV sphere, it doesn't actually do anything. The UV sphere just kind of is what it is. And then for the circle, it changes the resolution of both the circle that we're instancing and the curved circle that we're instancing along it. All right, so we'll stick with this circle for now because I think we could do something fun with it. And I say this is a circle, it's looking kind of wide. So what we can do is go to pommel thickness, we can turn that down, and then there we go. We've got something that actually looks like a circle now. And then what we can do with this is we can change the size with the size input, and then just like how we can control the depth of the handle, we can also control the depth of the pommel. And that's just to make sure that, you know, we get don't get any clipping going on right here. And then we can also choose to rotate it. This rotation is really most noticeable, or at least most useful, when you have a pommel shape of 0 and you're trying to use that. So we can, you know, make this a bit bigger, and then you can see, you know, and then with pommel depth, we want to make sure that it's set to 1 when it's on this pommel shape, or else it starts to be elliptical. All right, we can also subdivide this, and we can, you know, set the edge crease, and then we can add studs to it. Those studs are added to every single face. We can set the size and the resolution of those studs, and then we can also add a pommel spike. And this spike doesn't really work with the pommel rotation. That's something that I need to fix, but I'm kind of lazy. We can also add a gem to it, and we can set the size and material of that gem. So we can also see that I'm going to go back to our ring. I was kind of liking the ring. I'm going to make it a bit smaller, make it not as thick, bring the depth up a bit, and I want it to be a little bit bigger than that. All right, yeah, we'll go with that. That's neat. All right. And if we add a spike to this, you can see how it just gets a spike at the end, you know, and we can control the resolution, size, everything you want. All right, now, next up, we've got the fuller. So if you want a fuller on there, I'm gonna put it in wireframe mode so you actually see what's going on. You can see how we have this changing thing right here. But remember, this is technically the center of our blade. So if we have a single-edged blade like this, to get the fuller to show up properly, what we have to do is change the fuller offset. You can see how as we change that, the fuller goes back towards the middle of the blade. So we'll set this to material preview. You can see what that looks like. And that looks kind of small. So what we can do is change the width of our fuller. If you make this fuller width too big, you end up cutting a hole in the middle of the blade. If you want to do that, that's how you do it. For now, I think we'll just set this to 0.6. And then you can control how high up the fuller goes with fuller height. So as you can see, as we decrease it, it doesn't go as high. As we increase it, it goes higher and higher. We'll set it to 0.97. Let's see. No, we're getting clipping. It's going a little bit too high. So I'm going to just bring it back down to 0.93. And that's good. We can also choose the resolution of the fuller, depending on, you know, what kind of look you want. And I think for now we'll leave that at 3. And then we can also choose double fuller right here. And double fuller just makes 2 fullers. And then you can change the distance between these fullers using the double fuller distance. And then because these fullers are done using a mesh boolean, they tend to be pretty slow. Yeah, as you can see, it's taken 370 milliseconds. So again, this is one of those things where once you've got it how you like, I recommend then turning it off until you're ready to, you know, really put everything together. All right, so that's our fullers. Next up is our engraving, and this is pretty cool. You can put any string of text in here. We'll just say the quick brown dog jumps over the lazy fox. And as we can see, it's instanced along the center of our blade. But you'll see that, again, just like how our fuller wasn't actually in the middle, this also isn't actually in the middle. We can change that using the Y offset to get it where we want. We've got a lot of different engraving options that we can look at. And if we actually go up to our engraving node group, you can see here our initial string to curves. We can choose a custom font if we want. So our first thing is the engraving material. If I go ahead and finalize this engraving so that it actually applies the mesh boolean, you can see how whatever the engraving material is will then you know, be booleaned into the blade. So for instance, if we wanted it to be a Damascus engraving, I don't know how that would work, we can do that, you know, and you can see how that is via our texture applied in there. For now, I'm going to definalize the engraving and just set this back to the normal ink black. Now, this next option is to resample the engraving, which resamples the curve that is each of these letters, right? So each of these letters is initially made up of a curve, and by choosing this, we can resample that curve. And if we set that to the very minimum, which is 3, you see that we get this kind of weird hieroglyphic looking font. And then as we slowly increase it, you know, we can see our letters kind of start to take shape. And if you want to have like super scratchy letters, you can set this resample amount to be low. And if you want really nice high-res letters, I recommend just turning the engraving resampling off. because the standard letters as they are have like a really nice curve topology to them. Next up, we have the engraving resolution. This engraving resolution changes the resolution of the curve circle that is instanced along the curve, which is each of these letters. So as you can see, if we set this to the minimum, which is 3, it looks like that, and then as we increase it, it gets more and more vertices. We'll leave that at 3 for now. Go back to material preview. Actually, we'll go to rendered view. All right. So now we can look at the engraving size. This does exactly what it sounds like. It sets the size of the engraving, and the engraving naturally wants to follow along the center curve of the sword until it gets to the very top, at which point it just kind of jumbles up. So if you want it to take up the whole blade, you can do that. And if you want it to take up just a very small portion of the blade, you can also do that. But you'll notice that when we make it really small, the letters are all kind of bunched up real nice, and that's not great. So what we can do is we can change the engraving thickness, and that thickness, if we set it really low, is better for smaller letters, and if we were to have very large letters, we could set the engraving thickness to be quite large as well. But then you'll notice these letters are still kind of close together, which is where our engraving character spacing comes in. We increase that, and the spacing of our characters increases. And so we can set that to something like that, where the letters are sufficiently apart, where they won't run into each other. Now, engraving depth controls the depth of the engraving. By default, it's set to 1, and the reason that you would really change this is, let's say that you had a fuller in here, and then you went to apply your engraving, and you'll see that it doesn't really show up as well where the fuller was, right? So in that instance, we can increase our engraving depth, and it will and we can also increase our engraving resolution. Set that to 6. And then, oh, you can see that we went too far, and we're actually cutting through the whole sword. So we don't want to do that. So what we're going to do is we're going to unfinalize this engraving, and we can look and see. Yeah, so we're going too far. We don't want to do that. So we can go back to 1, and we can see that we're, oh wow, we're still going through 0.8. And there you can see we've got no letters coming through the back, but they are still sufficiently showing up where the fuller cuts through. Now, finalizing this engraving can take a really long time. This took 20 seconds, and that's because these letters are a boatload of geometry, and it takes a really long time. For instance, we've got, I'm going to definalize the engraving, and then it takes 0.29 seconds, right? So it's if you are actively working on it, I really recommend that you do not have this finalized engraving checked. And so if we look at these letters, we can see that currently we have 21,000 vertices. We're going to delete that string from the engraving. We're down to 6,000 vertices. It adds a ton of geometry. The engraving is very intensive, and that's part of why I have this engraving resampling there. So if we real quick, brown fox jumps lazy dog. If we just bring that back in, and we can see our vertices are back up, and then if we resample it and bring it down pretty low, you can see that we're still having, text and an engraving there, but the vertice count isn't astronomically high. So we'll leave that on there for now, and then I think we're ready to finalize this. So what we can do is go back up, check our blade chipping, make sure that looks as we imagined, and that looks good. So we've got just chipping. And then we can finalize our engraving. And then this is going to take a second. As you can see there, it took 24 seconds for the mesh boolean to calculate. So, but because that was the last thing we did, now we can just go up, apply our modifier, and then again, this is going to take a little bit, and then there we go. We've got our sword. So we can go back to this view, and then we can take a look at it, and it looks pretty good. We've got a fuller that's engraved. We've got wavy edges with some chipping going on. We've got a nice curved handle. And yeah, that is how you use the procedural sword generator. It's capable of making both single-edged and double-edged blades, like we've seen here. And the simpler blades, such as this, really don't have very much geometry at all. Really very simple. And I think they still look pretty good. All right, if you like this tutorial, you're more than welcome to download the project file from my Gumroad, link in the description, and I hope you learned something. If you make any cool swords with this, feel free to send them my way. I would love to see them. And again, you are welcome to use this in any commercial or personal applications, however you wish, no attribution required. All right, y'all have a lovely day.